Hi folks, and welcome back to Physics with Captain Rod here. The purpose of this video is to introduce you to the concept of Coulomb's law. And basically Coulomb's law is what allows us to calculate forces between charged particles. So for starters here, what I want you to imagine is I've got a pair of charged particles here. I've got one right here, which is positively charged, one right here, negatively charged. And before we move on, I want to talk quite a bit about what that means when we talk about a charged particle. And to be more specific, in this example, these charges are going to be point charges. So here's what a point charge basically is. Imagine a single electron. An electron is a particle that's negatively charged, right? So an electron can be considered to be a point charge. Or imagine a proton. A proton is a particle that's singly charged, positively charged. That can be considered to be a point charge. Or imagine a atom or molecule that's missing an electron. So if I had some sort of big molecule and it were missing an electron, then it would have a charge of +1. So typically that could be called a point charge. Or if it were missing 2 electrons, then it would have a charge of +2. And again, when I say +2, what I mean is 2 times 1.6 times 10 to the minus 19th coulombs, the standard unit of charge, right? So these charged particles, they could be electrons, they could be protons, they could be atoms that are either missing or maybe have extra electrons. All of those cases generally can be considered to be point charges. This thing also, though, could be maybe a little piece of matter. So imagine a piece of, maybe a cork out of a wine bottle or something. Now that's on the atomic scale, that's a pretty large object. But if you're quite a ways away from it and you look at it, all the matter's basically at one place. So if that cork carried a charge over its surface or something, as long as we're a reasonable distance from it, we can consider that to be a point charge. So when we talk about point charges, I usually mention this. Basically, if the object you're looking at looks like a doorknob, if it's far enough away that you can basically point to it and point to all of its surface to within reason, you can consider it to be a point charge. So these could be electrons, they could be protons, they could be atoms, or they can be small bits of matter that are charged that were far enough away that they basically look very small. Right? So these bits of matter, this one has some sort of positive charge, and I'm going to assign a variable to that. I'm going to call that Q1 here. And I'm not really sure why, but Q is the kind of the standard variable that gets assigned to charge. Whatever that charge is, it has to be some multiple or some integer times 1.6 times 10 to the minus 19th coulombs, right? Because that's the smallest unit on the atomic scale that charge comes in. You'd have to, get into smaller things to see charges that are different than that, right? This guy right here, I'm going to call the charge on that Q2. So I got two charges, Q1 and Q2. In both cases, whatever those charges are, they are multiples of the 1.6 times 10 to the minus 19th coulombs. Right? Now, because in the example I'm using, I've got a plus and a minus, right? These things are going to attract one another. So I can put force vectors in, all right, on both charges. And these forces, they would be equal in magnitude, opposite direction. That's Newton's third law. And Coulomb's law is the mathematical law governing these charges. So if I were to calculate the magnitude of F, right, using Coulomb's law, we find this, that the force depends on charge 1, but it also depends on charge 2 and the distance between these charges. Right? So it turns out that the force is directly proportional to charge 1, which means a constant times charge 1, and I'm going to call that constant K for a moment. It's also directly proportional to charge 2, which means basically charge 2 is being multiplied. And it varies inversely with the distance between these charges. Now, I'm going to go ahead and write this equation out. It turns out that not only does it vary inversely with the distance, but it turns out that it varies inversely with the distance squared. And what that basically means is if you double the distance between these particles, the force will be cut down by a factor of 4. If you triple the distance, the force will be cut down by a factor of 9, and so forth. Right? Now, Coulomb's law is an experimentally determined law. There's no deriving that, but it is fantastically accurate. It has this constant of proportionality. This is called the Coulomb constant, right? If you look in your book, this will probably say 8.99 times 10 to the 9th, and the units are Newton meter squared per Coulomb squared, right? This is dimensionally the units that this has to be in, so that this comes out to have the force in newtons. In most of the examples I work in this in any of my videos, I'll probably just approximate this to 9 times 10 to the 9th Newton meter squared per Coulomb squared, because that's, you know, about a less than 1% difference, or right around 1% difference, and it's a much easier number to for me to write and say and remember. So anyway, that's a little bit about Coulomb's law. Coulomb's law is really the fundamental force of electricity. So Coulomb's law is the force that binds, or that binds electrons to the atom. It's also the force that binds atoms together, really, to make molecules and so forth. So really, Coulomb's law is the fundamental force law that's responsible for the structure of matter. Very, very important force in physics. And again, the important thing here is that the Coulomb force depends on both the product of both charges, this one and this one, but it varies inversely with the distance squared. Now, inverse variation basically means that as the distance gets larger, the force gets smaller. And it ends up being distance squared for reasons that I'll talk about later. But I think that's probably good enough for now. So I hope this at least gave you some introduction to the Coulomb force. And in my videos upcoming, I'm going to talk about electric fields and how to calculate Coulomb forces and etc. So hope this video successfully introduced you to this mathematical law, and look for more videos in the future for how to use it. Have a great day.